Hello, good morning, students. So, today we are going to see a new chapter which is known as data abstraction. So, this data abstraction means hiding the unwanted data. Okay, so showing the meaningful and necessary data to the user and hiding the unnecessary data uh, is known as data abstraction. So, in this chapter, we are going to see what is data abstraction, abstract data structure, abstract data types, and the difference between concrete and abstract implementation. Okay, and pairs means two set of datas. Okay, so next is data abstraction in structure. So these are all the things that we are going to see in this chapter. Data abstraction is a powerful concept in computer science that allows programmers to treat code as objects. So for example, car object, pen object, pencil object, people object, etc. Programmers need not to worry about how code is implemented, they have to just know what it does. This is especially important when several people are doing a project. Here, project refers to the program with data abstraction. Your group members uh, won't have to read through entire lines of your code to understand. Okay, uh, you can just assume that it does work. Okay, uh, so when you are doing some big project, okay, uh, so many people will be doing your doing the same project, or involved in the same set of action. So if you are doing a different kind of programming, then it will be a it will be some making some confusion. So to debug errors, the senior manager will come and look into your project. So if you doesn't do any abstraction in the program, then he'll be finding difficult to understand your program. So before doing the entire project, they'll be doing some abstraction. So this abstraction will help others to understand your program very quickly. So by in which way they create abstraction means they'll create objects of each program. So object means the real world object, like mobile is your object, fan is an object, uh, everything, car, pen, pencil, bike, everything is an object. So like that, program is also an object. So they'll treat like a object this program. So the data will be abstracted there. Okay. So abstraction provide more modularity. Modularity means splitting a program into many modules. So classes are represented as abstract data types, ADT. ADT means abstract data type. So abstraction provides modularity, which means that a big program is splitted into many modules. Okay, so that's abstraction. So now next we'll see that abstract data type. Abstract data type is a type of object whose behavior is defined by a set of values and set of operation. The definition of ADT only mentions what operations are to be performed, but not how these operations will be implemented. It does not specify how much data will be organized in the memory and what algorithm will be used for implementing the operation. This is called abstraction. Okay, so here you can see that two things are given here. So it perform ADT mentions what operation to be performed, but not how the operation is implemented or done. How the operation is done, it's not given there. So it does not specify how the data is organized in the memory, and what algorithm will be used for implementing the algorithm. Okay, so these are all the things that are represented by abstract data types. Okay, so because it gives implementation independent view, the process of providing only the essential and hiding the details uh, is is known as abstraction. Okay, so you can see that these the definitions does not specify how the ADT will be represented and how the operation will be carried out. There can be different ways of implementing an ADT. For example, the list ADT can be implemented using single linked list or doubly linked list. Similarly, stack ADT and queue ADT can be implemented using lists. So uh, this paragraph is a small examples of ADT. Okay, list ADT is example of ADT, and it has two types: a single linked list and a double linked list. And stack ADT and queue ADT are the other set of examples. Okay, so data abstraction replicate how we think about the world. For example, when you want to drive a car, you don't need to know how the engine will was built or what kind of material the tire are made up of. You just have to know how to turn the wheels and press the gas pedal. The facility To facilitate data abstraction, you need to create two types of function known as constructor and selectors. So we'll see what is constructor and what is selector. Constructor are functions that build the abstract data types. Selectors are the functions that retrieve information from the data type. For example, say you have abstract data type called city. The city object will hold the city name and its latitude and longitude. To create a city object, you you, you didn't use the function like uh, city equal to make city name latitude and longitude. So to abstract information of the city object, you would u- you would use functions like get name, get lat, and get long. So following pseudocode will compute the distance between two cities object. So distance city 1 comma city 2, latitude 1 longitude 1 uh, equal to get lat of city 1 and get long of city 1. Latitude 2 comma latitude longitude 2, get lat of city 2 and get long of city 2. Return, okay, they are minusing, sorry, mm, they are subtracting the latitude and longitude and taking the square root, taking the square root of the latitude and longitude to find the distance between two cities. Okay, so this is a small program that is used to implement data abstraction in creating a city with so notice that you no need to know how these functions are implemented. You assume that someone else has defined them for us. It's okay if the end user doesn't know how the functions were implemented. However, the function still has to be defined by someone. Let us identify the constructor and selector in the above code. So you already know the constructor or function that builds the abstract data type. The above pseudocode, the function which creates the object of the city is constructor. So this line city equal to make city name lat and long uh, is the constructor statement. Here make city is the constructor which creates the city object. So here they give the pictorial representation of this abstract data constructor. So selector is uh, nothing but the function that retrieves information from the abstract data type. Therefore, in the above code, get name, get lat, and get long are the function that extracts information from the city object. So here you can see that data abstraction is supported by defining an abstract data type, which is a collection of constructor and selectors. Constructor creates an object binded together different pieces of information, while selector extract individual piece of information from the objects. Representation of abstract data type using normal rational numbers. So here they'll be giving a small example about nominator and denominator. We'll see that. Okay. So any program consists of two parts. The two part of program are the part that operates on a abstract data type and the part that defines the concrete representation is connected by a small set of function that implements abstract data type in terms of concrete representation. To illustrate this technique, let's consider an example to design a set of function to manipulate rational numbers. Rational number is a ratio of integer, and the rational number constitute an important subclass of real numbers. A real number such as 8 divided by 3 or 19 divided by 23 is typically written as nominator slash denominator. Okay, so here nominator is 8 and denominator is 3. So when where both the nominators and denominators are placeholders of integer values, both parts are needed to be a structure characterize the value of a rational number. Actually, dividing integer produces a float approximation, losing the exact precision of integer. So here, when you divide two numbers, uh, two integer number, that is two whole numbers, you'll be getting a fractional numbers. So here you are just losing the precise information. Okay, you are just losing the precise integer accuracy, so it is broken down into uh, decimal values. Okay, so that is fractional values. So that what is it's given here, and here you can see that. However, you can create an extract representation for rational numbers by combining together the numerator and denominator. As we know, for using functional abstraction, we can start programming productively before you have an implementation of some part of our program. Let us begin by assuming that you already have a way of constructing a rational numbers from a numerator and the denominator. You also assume that given a rational number has a way of selecting its numerator and its denominator. So with this we'll finish the class today. We'll see the rest of the things in the next class. Thank you, students.